Hi everyone, Dankman here, continuing our topic of how to do this elimination strategy for solving systems of equations. Here's a new example. So the instructions for this example problem are solve the system. And here's the system of equations. Whoa. Third time's a charm. Here are two linear equations. Negative 8x minus 9y equals negative 24. 2x minus 9y equals 6. Can we solve this system of two equations? So I'm not going to graph it, and I'm not going to use substitution, because the point here is to think about how to use this cool strategy, linear combination or elimination. And today we introduced this idea that we could add two equations together or even subtract two equations, or use subtraction, subtract one equation from another. So the general strategy that we've been looking at is like this. I take one of the equations and I add or subtract the left-hand side of that equation to the left-hand side of the top equation, and I add or subtract the right-hand side of that equation to the right-hand side of the top equation. And in this case, I'm looking at it and I'm thinking, how do I eliminate one of these variables to create a single variable equation? So if I add together negative 8x and 2x, I won't eliminate the x's. And if I add negative 9y plus negative 9y, I won't eliminate the y's. But if I subtract the bottom equation from the top equation, watch what happens. I get negative 8x minus 9y. And then I'm going to essentially distribute this negative sign and subtract each thing there. So I'm going to subtract 2x, and I'm going to subtract a negative 9y. This goes way back to algebra tiles type stuff, where we have to subtract a negative 9y. And on the right-hand side, I have negative 24 minus 6. Okay? Rearranging a little bit to allow myself to clean up, I'll pull my negative 8x minus 2x terms to the front, and then I've got negative 9y minus negative 9y. And then on the right side, I have negative 24 minus 6 will give me negative 30. Negative 8x minus 2x, I can now combine to give myself negative 10x. And now I have to figure out what to do with this. So I have negative 9y, and I'm subtracting a negative 9y. Quick algebra tiles review. Here are negative 9y tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9. They're empty, so they're negative. Okay? They're in the top. In the bottom, in my subtraction region, I have 9 negative y tiles. 1, 2, 3, 4, 5, 6, 7, 8, and 9. To combine them, I'm going to flip my negative 9y tiles to the top and fill them in. Okay, and once I fill those 9 tiles in, they become positive. Now I have negative 9y tiles and positive 9y tiles together, and they eliminate as a zero pair. They annihilate each other. So negative 9y minus a negative 9y becomes negative 9y, or minus 9y plus 9y, and that's a zero pair, so I'm left with just negative 10x is equal to negative 30. Okay. So before I move on, quick review. I wanted to combine these two equations using addition or subtraction. When I looked at combining with addition, it did not eliminate a variable. But if I do negative 9y minus a negative 9y, then I eliminate those y's. So because the 9y here and the 9y here are both negative, they have the same sign as each other. If I use subtraction here when I combine my equations, I will eliminate the y's. Okay? So if the coefficients are the same size, same number, and the same sign, positive or negative, then we can subtract to eliminate a variable. I don't recommend memorizing that rule, but it's not even a rule. Moving on, let's finish this system. So now I have negative 10x is equal to negative 30. I should be able to solve that with some clever moves here. Divide both sides by negative 10. X is equal to positive 3. To solve the entire system now, I have to figure out what x should be equal to, and then what y should be equal to. Given that I know x is equal to 3, I substitute in 3 for x. Now I have a single variable equation, negative 24 minus 9y is equal to negative 24. I'll add 24 to both sides, and I get negative 9y is equal to 0, which means y is equal to 0, which means my solution is x equals 3, y equals 0, or the ordered pair 3, 0, and I will leave the check to you. I'll tell you this, I'm not positive that this is the correct solution to this system of equations, so if you perform the check and find that I've made a mistake, and shoot me a Google Classroom, or an email, or a remind, or a parent square, or any kind of response, and let me know where I made a mistake, what it was, and what the correct answer is, so whoever can find my mistake first, if I made one, I don't know if I did, I will give you a prize. I hope you enjoyed this example. Tomorrow we're going to continue working with elimination, but we're going to look at even more complicated elimination problems, and that's going to be the end of introducing this new topic of elimination, and we'll move on to actually using it and practicing it.